All right, let's look at question 5. This is the AP Calculus BC exam, 2021, number 5. I have not read it yet, so we'll see what happens here. At a glance, this is a Taylor series, Euler's method, differential equations. Oh my goodness. Oh, there's a parts in there. Yikes. Okay, so we have a differential equation, dy dx is equal to y times x ln x. F of 1 is 4. It can be shown that f double prime of 1 is 4. That's interesting. Why didn't they just say f double or whatever? All right. Write the second degree Taylor polynomial about f for f about x equals 1, and then use that to approximate f of 2. So this is going to be a fairly nice question. We're just going to use our generic formula, the nth derivative at 1 over n factorial times x minus 1 to the nth power. And so my f of 1 is 4, so that'd be 4 over 0 factorial x minus 1 to the 0 plus f prime of 1, which would happen here. So that's my derivative at the point 1, 4 is going to be 4 times, oh really? 1 times the natural log of 1? What? That's 0. Holy cow. So they want the second degree. They don't specify the number of terms. Okay, cool. So it'd be 4 plus, I'll write it in here, 0 over 1 factorial x minus 1 to the first, but that's just 0. And then my second derivative, they told you f double prime of 1 is 4 over 2 factorial times x minus 1 squared. And then they tell you to approximate f of 2. So f of 2 would be approximately 4 plus, oh, I see what they're going to do with this. Do they? Oh, they don't. I thought they were going to ask for max or min. Okay. So that zeroes out, and then I have 4 over 2 factorial is 2 times 2 minus 1 is 1 squared. That's going to be approximately 6. You don't have to clean it up, and I would encourage you not to, but there is your answer for A. Euler's method, 2 steps, equal size. I'm a fan of doing Euler by table. Just make sure if you go to the table method, you very meticulously label it. So we're starting at x equals 1. We want to use 2 steps to get to f of 2. So that means I'm going to go up by 0.5s. So here's my table. I'll make it kind of big. So I'm starting at an x of 1 and a y of 4. I do not know what my new y's will be. My change in y is going to be, okay. My change in y is y times x ln x times my delta x, which would be 0.5. And I may want to make a note here, delta x is 0.5. That looks like a minus 5. Times 0.5. And then I want to establish how I'm getting my new y coordinates, and that is by taking the previous or the old y coordinate and adding my newly computed delta y. And so let's start plugging these in. So I already know that dy dx at this point is 0. I did that in part A up here. So y times x ln x is going to be 0 times 0.5, which is going to be 0. So now I need to add 0 to my previous y coordinate of 4. So I'm still at 0. Then at 1.5, here's where it's going to get a little bit ugly. It's 4 times 1.5 times the natural log of 1.5 times 0.5. And this is really interesting that they gave you something like this on a non-calculator question. And it doesn't make a huge difference, but my new y coordinate is going to be 4 plus all of that stuff. I think I'm going to go ahead and say 4 times 1.5 is going to be 6 times 0.5 is going to be 3. Natural log of 1.5. And so that is your final y coordinate that we will put here. So f of 2 is approximately 4 plus 3 natural log of 1.5. And that is really atypical for them to put something like that where you cannot at least get a common denominator and combine it. But that's okay. I mean, they can do that, whatever. All right, so part C is to find the particular solution to that differential equation with the initial condition 1, 4. So here we get to do some parts inside a separable differential equation. How nice is that? So you always want to separate your variables first. So dy dx, nope, we're going to divide by y. dy over y is equal to x times the natural log of x dx. And when you integrate both sides, left side is nice, natural log of y. I'm going to do my parts over here on scratch paper. So x ln x dx. Your u would be the natural log of x. Your v prime is going to be x. U prime is 1 over x. Your antiderivative of x is x squared over 2. And so that gives me x squared over 2 natural log of x minus 1/2 the antiderivative of x, which gives me, finally, over here, x squared over 2 natural log of x minus, and that will be 1/4 of x squared when you integrate that thing, plus c. My initial condition is 1/4. I typically, when I have a natural log in a differential equation, I will solve for y before I solve for the c. But I think in this case, should I? Yeah, I guess I will. So I'm going to go ahead and solve for y. So that'll be a e to the x squared over 2 natural log x minus 1/4 x squared. And I'm going to plug in the 0.14 now. So if I plug in the 0.14, that'll give me 4 is equal to a e to the, that's all going to be a 0 to the negative 1/4 when you plug in 1. And so we get 4e to the 1/4 is equal to a. So now I can write my solution. Y equals 4e to the 1/4 times e to the x squared over 2 natural log x minus 1/4 x squared. I would typically stop there, but you could also write this as 4e and then move that 1/4 and add these exponents up here. So 1/4 plus x squared over 2 natural log x minus 1/4 x squared. And there's my answer for part C. And I believe that's it for this one. And it is. Stop recording.